Hi guys, welcome to your 9-5 notes, completing the square. By the end of the day, you will be able to solve quadratic equations by completing the square. This is useful for solving real-world problems that are modeled by quadratic, also known as squared, expressions. In previous lessons, we solved quadratic equations by finding square roots and by factoring. So we did square roots and we split it up and set it equal to 0, and then set those equal to 0, right? But sometimes that's too hard. Sometimes it just doesn't work. So today we're going to learn a new method called completing the square. So you can solve any quadratic equation by writing it in the form of something squared equals something else. You'll have this expression, you have some thing in parentheses with this squarey guy there equal to another number, and we can solve from there. In fact, we're going to use a shortcut from a couple lessons ago to help us. We learned earlier about a perfect square trinomial. Now, a perfect square trinomial is one that looks like a squared plus, I don't want to use a, I want to use m. It looks like m squared plus 2mn plus n squared. When you have that pattern, we know that that's going to be equal to m plus n squared. Because you have squares on the outside, you have 2 times their square roots in the middle. That's m plus n squared. That's from chapter 8. We are going to use that shortcut to our advantage today. First, let's factor each perfect square trinomial. Here in example 1, we have x squared plus 8x equals 16. I know this is a perfect square because the square root of x squared is x, the square root of 16 is 4, and this is 8x is equal to 2 times x times 4. Therefore, I can use our perfect square shortcut. That's equal to x plus 4 squared. Again, we've got x squared plus 4 squared, so that's x plus 4 squared, since we've got the 2 times x times 4 in the middle. You'll also notice a cute little shortcut, that this 4 right here, this is half of our 8. Keep that in mind. We've got another more complicated one. Let's see if this one is a perfect square trinomial. The square root of 4a squared is 2a. The square root of 9b squared is 3b. Now in the middle, is this equal to 2 times 2a times 3b? Almost, it's got a negative, so this 3b needs to be negative. So that means this is equal to 2a minus 3b squared. Again, we've got something squared and something squared with the 2 times them in the middle. So we've got our perfect square trinomial shortcut. And finally, let's use our perfect square trinomial shortcut here. This is equal to something squared, and let's find out. That's equal to c squared. 64 is equal to 8 squared. And in the middle, this is going to be equal to 2 times c times 8. Oh, it's got to be negative 8. Again, we've got our c, our negative 8. So this is equal to c plus negative 8, or c minus 8 squared. That's our perfect square shortcut right here. M squared plus 2mn plus n squared. If you haven't highlighted that and loved that, put stars by it maybe, you should. It's very important. Especially this 2 right here. Notice that we can take the squares off and put a 2 right in front, and that gives us our middle term. So we looked at that with number A. So that's our 4, half of 4. Our 4 is half of our middle term, 8. Cool. Same thing in C. negative 8 is half of our negative 16. This is going to come in handy. So that we've looked at that pattern, we're going to kind of mess with it a little bit. In example 1, you were given the whole perfect square trinomial. But here, you only have 2 terms in example 2, and you need to find out what is C going to be to make this a perfect square. Well, let's use this half of trick to help us out. Okay, so we want that this will be equal to x plus something squared, just like up here. This is going to split up into x squared. This needs to be something squared, but we don't know what. We do know, however, that whatever is here, that's going to be half of 18. And what's half of 18? Oh, 9. 9 is half of 18. That means that our C is going to be 9 squared. And 9 squared is 81. So we want to put an 81 there. This is because x squared plus 18x plus 81 is x plus 9 squared. I think this is a perfect square trinomial, so we wanted to add 81. Sweet. Let's do our next one. In B, we want B to be equal to something squared. Well, we know our first term is G. Looking for G squared. Here we want to make this equal to something squared. We don't know what, so we've got our G plus something. We don't know what, but we do know that thing is going to be half of negative 30. Well, what's half of negative 30? It's negative 15. Awesome. Since this is negative 15, we know that C is going to be equal to negative 15 squared. Negative 15 squared is 225. So the number that we want to add is 225. And adding 225, oh shoot, no, I'm good. I'm just looking at the wrong problem. Okay, so in adding 225, that will give us G squared minus 30G plus 225. That is a perfect square trinomial equal to G minus 15 squared. So we add 225. And finally, let's look at C. We want to make this equal to something squared. Now our first one, we've got Z quantity squared, so we'll put Z in front. And whatever is going to go in the back, we don't know what it is yet, but we do know it's going to be half of 10. Well, last time I checked, half of 10 is 5. Awesome. That means C is going to be 5 squared. 5 squared is 25. So we want to add 25 to make this a perfect square trinomial. Let's check if that works. So if we have Z squared plus 10Z plus 25, that is equal to Z plus 5 squared. Awesome. So 25 is the number we're going for. Again, to make a perfect square trinomial, we are trying to make it fit this pattern right there. So what did we do here? Well, to complete the square, if we were given x squared plus bx, to make that a perfect square trinomial, we found out, okay, well, what is half of b? So we took half of b, that's b over 2. I'm going to write that. We wanted to find what is half of b. So half of b is b over 2. And then we took what that was and we put it here by squaring it. So we take b over 2 and square it. And that's going to be our shortcut right there. Not even our shortcut. I said not even our shortcut, our rule, but there you go. So to complete the square, here's our key idea of the day. Awesome. If we have x squared plus bx and you need to add something to that, what you want to add is b over 2, that whole thing squared. Okay, well that's our whole concept. So let's go ahead and solve each equation using completing the square. So here in A, we have d squared minus 6d equals 247. And this does follow our pattern of x squared plus bx. We want to figure out, okay, what do we need to add here to make this a perfect square trinomial? Well, let's use our shortcut. In fact, I'm going to copy it because we'll use it a lot today. Again, we want to find a number that is half of b and then we're going to square it to add there. So b over 2 squared. Here our b is negative 6, so that's equal to negative 6 over 2 squared is negative 3 squared. Negative 3 squared is 9. So we want to add 9 to the side of our equation to make it a perfect square. I should have rewritten this. Hold on. You know what? I'm just gonna replace this. I can do that. Okay, so we have d squared minus 6d, and then we wanted to add 9 here. So let's go ahead and add 9 to our equation. But wait guys, this is an equation, so we need to add 9 to the other side too. That is super important. Remember to add to both sides. Okay, so now we have this new equation. I'm going to write it down below our work just for clarity. D squared minus 6d plus 9 equals 247 plus 9, that's 256. Okay, so here's our new equation. Now we want to solve that. Fortunately, we can clean this guy up. The whole reason we wrote him is because he's equal to something squared. And using our shortcut, we know that he's equal to d plus whatever was in here, and that was negative 3. So we take the square root of d squared, gives us d. The square root of 9, negative 3, equals 256. Now, to solve here, to undo this, I'm going to rewrite him real quick. To solve this, we want to get our d all by itself. So I want to get rid of that square by taking the square root. Those will cancel out, giving me just d minus 3. And the square root of 256 is 16. Wow, that worked out so nice. Except wait, square roots have 2 answers. That is plus or minus 16. And we're almost there. You guys, we are so close. To solve this plus or minus, you have to split them into 2. So that will give us d minus 3 equals positive 16. D minus 3 equals negative 16. I'm going to add 3, giving us d is equal to 19. And we're going to add 3 on this side as well, giving us that d is equal to negative 13. So we have two solutions. D is equal to 19 and d is equal to negative 13. Now that we know what d is, we can take it and plug it back into our original equation and say, hey, is it true that 19 squared minus 6 times 19 equals 247? It is, I checked already. And is it true that negative 13 squared minus 6 times negative 13 equals 247? It is, I checked already. So we did this right. Awesome job, guys. And that's how to complete the square. Let's recap our steps. What did we do first? Well, first we used our b over 2 squared to complete the square. Then we rewrote as a square, and then we took the square root, and then we split and solved. Those were our steps. Now we're going to put each of those steps on each of these problems. Ready? Here we go. All right, for b, we have k squared plus 9k plus 15 equals 0. Now, guys, this does not follow our pattern. We wanted something that looked like x squared plus bx equals something else. But that's okay. We can take this 15 and move it to the other side by subtracting 15. So now we have k squared plus 9k equals 0. That's not 0, equals negative 15. And that's a lot better. That's what we're going for. So now we need to complete our square. Keeping in mind our shortcut, let's plug this guy in. So our 9 is our b term. So that gives us 9 over 2 squared. 9 over 2 quantity squared is 81 over 4. If you would rather write 20.25, we can do that as well. If you would rather have written, oh, that's 4.5 squared, that's fine. That's 20.25. Alrighty, so that means we need to add 20.25 to our equation. And that will complete the square. But remember, what you do to one side, you have to do to the other. So you need to add to both sides. Let's rewrite what we have real quick. So we have k squared plus 9k plus 20.25 equals 5.25. Cool. Now, I know this side looks kind of messy, but the whole reason we wrote it like that is because that is a perfect square trinomial. What is it a perfect square of? Well, we need to take our first term using our shortcut backwards, k, and our second term. Remember, we got 20.25 because that's equal to 9/2 squared, or 4.5 squared. I'm going to just write 4.5 equals 5.25. Awesome. Now, how do we solve this? Well, we're going to take the square root of both sides. So let's go ahead and do that. The square and the square root are going to cancel out, and that will give us just a plain old k plus 4.5. And then the square root of 5.25, you guys, is not very nice. We're going to round it 2.29, keeping in mind, since we took a square root, we need to do plus and minus. Now we're almost there. Since we have our plus or minus, we need to split them into two equations. So we have k plus 4.5 equals a positive 2.29, and k plus 4.5 equals a negative 2.29. Now that we have each of those, we can solve by subtracting 4.5. So on this side, we're going to subtract 4.5 on each side of our equal sign. That gives us that k equals negative 2.21. Whoops. Better. And on this side, we're going to solve for k by subtracting 4.5 on each side. And that gives us that k equals negative 6.79. So we have two solutions. Now let's plug it back into our original equation and check that it works. I did already, I promise you they work. So again, here we started out by using our shortcut b over 2 squared, and that gave us our completion of the square, so we completed our square. Then we rewrote our perfect square trinomial as a perfect square, took the square root, and then split and solve. We have one more. Go ahead and try this on your own. Pause the video, try it on your own, and see if you can get the same answer that I did. Did you end with p equals 2 and p equals negative 4? If you did, awesome. Take a breather. If not, let's go ahead and work through this problem together. So here we've got p squared plus 2p equals 8. And we want that to look like x squared plus bx plus c equals 8. We need to figure out what's going to go in this plus c part. So we've got p squared plus 2p plus something equals 8. Let's go ahead and put our shortcut here. Now here our b term is 2. So 2 over 2 squared is 1 squared, which is 1. So we want to add 1 to both sides. We add 1 here because this makes this a perfect square. We add 1 here so that they can balance. Alrighty. Now we're going to keep the square root of our c term in mind because this will help us write it as a perfect square trinomial. So to recap, we've got p squared plus 2p plus 1. And that's equal to just a plain old 9. Now we did this because we have p squared plus 2p plus 1. That is a perfect square trinomial. That's equal to something squared. What is it squared? Well, square root of p squared is p. Square root of 1 is 1. Awesome. So p plus 1 squared is 9. Now to solve that, oh, also, how did I get this? Where did this come from? The square root of our c term we found by finding c in the first place. That's where he comes from. Okay. So let's go ahead and solve for p. Well, to solve this, we want to get rid of our square. We're going to undo a square by taking the square root. That will undo all of our squaring work. So we just have p plus 1 equals the square root of 9 is 3. It's plus or minus 3. Thank you. So now we need to split them up. So on this side, we've got that p plus 1 equals a positive 3. Over here, we've got p plus 1 equals negative 3. If we subtract 1 from each side over here, that'll give us that p equals 2. If we subtract 1 on this side, that gives us that p equals negative 4. Oh, hey, that was the solution. Let's go ahead and check our work real quick. If we want to check that we did this correctly, we're going to take what we got for p and plug it back in to our original equation. So is it true that 2 squared plus 2 times 2 equals 8? Is it also, well, yeah, let's find out. So 4 plus 4 equals 8. Awesome. Let's check our other solution. Is it true that negative 4 squared plus 2 times negative 4 equals 8? Oof, I don't know, guys. Let's find out. So that's 16 plus negative 8 equals 8. Well, that's the same thing as 16 minus 8 equals 8. That is true. Awesome, we did it right. You guys, we completed the square 3 times. Way to go. Now, Ms. Van Dyke, when are we going to use this in real life? Well, I'm so glad you asked. Let's say that it is tulip time, and you are growing Ms. Van Dyke's favorite flowers. Yes, tulips are my favorite flower. So, that's fun. You're planting a flower garden, and it has 3 square plots, 1, 2, 3, surrounded by a 1-foot wide border. The total area of the garden and the border is 150 feet squared. That's our total area. What is the side length x of each square plot? Well, let's find out. So, what do we know? Well, we know our area is 150 square feet, and we know this is a rectangle. The area of a rectangle is length times width. So our length is represented by this whole distance here, and our width is represented by this whole distance here. So let's look at what our width is. Our width has a foot on top, a foot on bottom, and x. So that means our width is x plus 1, which is 2. And what do we know about our length? We know our length has a foot on this side, a foot on that side. That's 2 plus 3x. So we have 3x plus 2. So now that we know our area is length times width, we know our length is 3x plus 2. We know our width is x plus 2. So let's go ahead and plug those in. So our area is 3x plus 2. And our width is x plus 2. We also know our total area is 150. Believe it or not, you guys, we have a quadratic equation ready to go. Let's go ahead and clean it up a little bit and then find its solutions. Can't clean up our 150 yet, so we're going to work on this side. I'm going to distribute first my 3x to x and then 3x to 2. That'll give me 3x times x is 3x squared. 3x times 2 is 6x. And then I'm going to distribute my 2x plus 2 times 2. Gives me 2x plus 4. I can combine these two like terms in the middle here for a total of 3x squared plus 8x plus 4. Hey, look at that nice quadratic. Equals 150. Now we want to use completing the square. So to do that, we're going to get this 4 to the other side real quick. And that will give us 146 equals 3x squared plus 8x. And we want to figure out, okay, to make this a perfect square trinomial, what are we going to add here? Before we do that, actually, let's clean this up just a little bit. I don't like this 3x right here, so we're going to divide everything by 3. It'll make it a lot easier. So that'll give us 146. In fact, let's just do this. 146 over 3 equals x squared plus 8/3 x. Cool? Okay, that's much better. Now let's use our shortcut. Whew. Okay, so here our b is 8/3. So we're going to plug that guy right in there. That gives us 8/3 divided by 2 squared. Well, 8/3 divided by 2 is 4/3. So we want to find out, what is 4/3 squared? 4/3 squared is 4 squared over 3 squared, 16/9. So we want to add 16/9 to each side. So we're going to add 16/9 on this side and 16/9 on that side. Don't worry, guys, I did all the hard math for you. That'll come out to 454 over 9. Yay. Now we made this guy right here because we want him to be a perfect square trinomial. Well, we know it's a perfect square because we've got our x squared. Again, we want it to be a perfect square. That's why we completed the square. So it's going to be x plus something, quantity squared, and that something is the square root of 16/9, which is 4/3. So we add our 4/3 up in here. Nice. All that's left is we take the square root to solve it. And we get x plus 4/3 equals plus or minus the square root of 454 all over 3. Now, in solving this, that will give us that x is approximately equal to 5.77, or x is approximately equal to negative 8.44. We're almost there, but not quite. Because remember, what does x represent? X is a distance. X is the length of one of our squares. We can't have negative length. Negative length is not a thing. Because we can't have negative length, we call this an extraneous solution. It's extra. We don't need it. So our squares are, for realsies, 5.77 feet long. There it is. So again, to complete the square, you need to have something squared. You need to have x squared plus bx. Then we use our shortcut, super important. B over 2, that quantity squared, is what we add to both sides. We rewrite our perfect square trinomial as its factored form, something squared. Take the square root, split, and solve. Look at all this knowledge, you guys. You did amazing. You're fantastic. Love it. Remember to keep in mind your shortcut. This shortcut informed what we add to our square, this guy right here. I hope you enjoy your homework.